So we're going to be talking about plugins here in this course. All right, so this session is recorded. You will get a link to all the materials by Monday. If you have a question that is relevant to what it is that I'm talking about at that point in time, use the QA widget. So you should see it somewhere on the bottom of your screen. If not, look for the 3 buttons on the right-hand side where it says Q&A. You'll say Q&A and you should see kind of like a pop-up menu where you can add a question. Use that to add your questions because that's kind of where I will be monitoring for questions as I progress along. All right, real quick, just to clear this up. Okay, what is it that you would like a link to? Because I've linked to everything that I've discussed already. So if you scroll up, you'll see links. Those are links that you need. So all the links are up there, right? There are no certifications for attending this workshop, but if you do need any type of like proof of attendance or something like that, just let us know when you get the email with the resources, and we can provide that for you. We'll start at a high level conceptually before kind of moving into some code. Again, just given the fact that most folks here on my initial kind of my initial vibe check, a lot of people said they were not familiar with 51. There's about 20 people that have joined since the start. So my question to everybody at the top of the hour was, if you are familiar with 51, if you have used 51, drop a 51 in the chat. If you have not used 51 before, or you're brand new to 51, drop a 50 in the chat. This is going to help me kind of gauge which direction I'm going to take the rest of the presentation. So for those of you that joined, just let me know. Drop a 50 or 51 in the chat. All right. So again, this workshop is designed with the assumption that you already know 51 and you're kind of looking to become a power user. If you're absolutely brand new to 51, of course, you're welcome to stay. You'll likely better benefit if you go to one of our getting started workshops and spend a week hacking around with 51. That being said, I have dropped a number of resources in this chat. You will get links to those resources when we send out an email, kind of like the recap email. So if you miss those links, don't worry. You'll, either somebody else who has the links, please drop them in the chat, or just wait until we get the recap email. Again, more than welcome to stay. And, hopefully you plan on attending the Get It Started workshop, or, go through the Coursera course that I mentioned and all that. All right, so let's go ahead and just talk about the agenda at a high level. We're going to do an overview of 51 plugins. I'm going to talk to you about how to install and use a plugin. We'll go through an overview of the plugin development process. Instead of developing a plugin together, what I'm going to do instead is I'm going to pull up code for a plugin and kind of, we'll look at a few examples until you kind of pick up on the pattern of what you need to do to implement the plugin. But again, we won't implement one from scratch, just given that there's not a lot of 51 power users here. I'm Harpreet Sahota. I'm a hacker in residence here at Voxel 51. Background is in math and statistics. Used to work as an actuary, a biostatistician, a data scientist. I've been doing deep learning for now about maybe 4 years or so. I've worked at places like Deci AI, Pachyderm, and Comet. And my main role here at 51 is building integrations for the open source library. So here's a link to my GitHub here. You can see all of these kind of integrations I'm building into 51, whether they're kind of plugins or models or, hosting workshops and hackathons, things like that. That's all what I'm kind of in charge of. You can see I'm pretty active in my contribution to the 51 ecosystem. So feel free to drop a follow on GitHub. You can stay up to date with what I'm doing. My kind of area of most interest is generative AI, vision language, and things like that. So that's kind of, the thing I'm most interested in, vision language models at the moment. About Voxel 51, we're the lead maintainers of the open source library called 51. our whole premise is making visual AI a reality, and we do that because we help make visual AI a reality by helping you engineer and curate better data sets. What exactly is a voxel? Well, a voxel is to a video what a pixel is to an image. It's just a volume element in the space-time volume of a video. Why 51? That is a good question. I'm pretty sure it's because the founders had 50 bad ideas before having this one good idea. Yeah, so the main thing we're going to talk about today is plugins. So what is a plugin? A plugin is just a software component that extends the functionality of that existing software, application, or library without modifying its core code. In the context of a open source library like 51, plugins will help you do several things, and they serve several purposes. At the core, a plugin is kind of a dynamic add-on that will help you extend the functionality of 51. And they work like building blocks. You can snap them in when you need new features. You can remove them when you don't. And what makes them special is that they're independent. So each plugin is a standalone module that follows a defined integration guideline. You can install, update, or remove plugins without touching 51's core code or disrupting your existing work. And so plugins are what makes 51 more versatile and encourages community collaboration. So a user can create and share a plugin that solves a specific problem. And again, that will end up making 51 more powerful for everyone. So the plugin architecture, again, it's what makes 51 versatile, and it also will encourage community collaboration because you can create and share your plugins that solve a specific problem for you. But you might realize that this actually solves problems for a lot of people. And so you can make your plugin open source. And again, this will help make 51 powerful for the entire community. So plugins make it easy for you to do your work. It'll help you save time by making a kind of complex or tedious task into kind of a point and click operation if you implement the plugin via the app, or just helps you kind of focus on more on the data work. And so you don't have to dig through old scripts and dig through kind of stuff that is kind of spaghetti code, repetitive code, and things like that. And of course, when you can better understand your data, you'll be able to find quality issues, you can train better models and deliver more value. So plugins help you save time. And some examples of some plugins, I'll go ahead and talk to you about a few, and then we'll see some in action. One of these plugins that we have is what's called the utilities plugin or the Utils plugin. And this is just a collection of essential data management operations. And this will allow you to perform these operations directly from the 51 app. So you can create, load, clone, and delete a data set. You could edit data sets and metadata and properties of your data set. You can rename data sets, delete data sets. You can compute metadata for your collections. You can generate thumbnails from media. And you ultimately execute arbitrary functions via delegated operator. So everything that you see here in this plugin form, right, you can, of course, do all this programmatically using the SDK, but with the plugin into the app, it just makes it a point and click operation. So you end up kind of saving time. We also have a plugin for model evaluation. And so this is, of course, just like the name says, it's focused on model evaluation capabilities that 51 has. So it's a GUI wrapper around the 51 evaluation methods, and it makes it easy for you to access model performance directly from the app without having to write any additional code. And so this is nice because you'll be able to quickly analyze how well your models are performing on different data sets, or how different models perform on that one data set. And you can perform the evaluation across classification, detection, segmentation, regression, the common computer vision tasks. And then once you run the evaluation routine, of course, you can visualize all this in the model evaluation panel, which we'll see all this in action in a little bit. But this will give you more insight into the evaluation information and metrics. You can load the evaluation views, you can rename evaluation runs, and you can delete evaluations as well. We also have the IO plugin. So this is just all about importing and exporting data in 51. So again, it's a GUI wrapper around kind of the functionality that we have in the SDK, and lets you handle common data input and output tasks without writing code. And this is useful when you want to import new data, merge data sets, or export some annotated samples to do some other downstream work. So this is quite nice and helpful. And we'll see this in action, actually. Another plugin that we have is a plugin around our zoo. So we have a model zoo and a dataset zoo. And what this plugin allows you to do is just makes it easy for you to access pre-built data sets and models without having to, write any additional code. So very useful for quick experimentation or when you want to try out some different models on your data. So what you could do here is you could download and load data sets from the 51 dataset zoo. You can configure dataset splits and parameters, and you could download and run models from 51 Zoo, run different types of inference, things like that. So it's very handy and useful and helps you save time from having to write code, especially if you're kind of in the middle of like an app-based workflow. This is quite useful for that. Another plugin that we have, we'll take a look at this today as well. This is what's called the dashboard plugin. So the dashboard plugin allows you to create custom dashboards and helps you visualize, various properties and statistics and metadata of your data set. So it's just a visualization tool that's going to help you kind of get that more, help you do EDA on your data set in kind of a more a bar chart and histogram and pie type of way. So this is nice because, if you have some common types of plots that you tend to do, you can save those as a saved view. And so no matter what data set comes in, you can save these button clicks and just run that view, that saved view, so that you don't have to, continuously click around and stuff like that. So we'll show you how to do this as well. And here are just some other kind of fun, interesting plugins that we have here. This is a PDF loader plugin. So you can work with, essentially, if you have a collection of PDFs, you can load them in as images into 51, and you can do some interesting things with that PDF. A couple of interesting things that you might want to look into. I'll drop a link into this in a second. One of them is this plugin for NEMA Retriever Parse. This is using NVIDIA's API. And so you can, if you use a PDF loader to load your PDFs into 51 dataset, you can then run this plugin on there and do some kind of text extraction. Another one that complements this actually is something that we just integrated. It's not as a plugin. This is as a remotely sourced model zoo. So this is Llama Index's visual document retrieval model. So I've integrated this as a 51 model zoo. So now you could do essentially natural language search over a document data set. So that's a nice kind of functionality to have. Of course, these are some other ways you could use this plugin. You can do the text extraction and do natural language search again over that. Is it free to use? So 51 is an open source library for sure. 51 is free to use. If you're talking about the NEMO parse retriever model from NVIDIA, that does require an NVIDIA API key, but the NVIDIA folks at NVIDIA, I think, give you something like, 1,000 or 5,000 credits for free upfront, so you can test the model. And once you've got that, then you can use that. The visual document retrieval model, that's a local model, open source model that Llama Index has released. So that one is also free to use. That's just run locally rather than over an API. All right. And here are some just really kind of creative ways that you can use a plugin. So here's a plugin that a community member of our built that does kind of reverse image search in the app. So essentially what we're doing is we're taking, if you have a data set of images, and now you have a new sample coming in and you want to find the images that are most similar to this new sample, then you can do that using this reverse image search. Kind of behind the scenes, everything is done using kind of embedding based workflows. But just to give you an idea of how creative you can get with plugins. Of course, you could do a multimodal retrieval plugin. This is an example of one using the image bind library, or rather the image bind model. So the image bind model actually is 6 modalities, I think, in one. And so what we're doing here is we dropped a sound clip of a train, and what the model does is it'll take that sound clip from the train and find the images that are most likely to make that sound. So that's what happened here. We dropped a sound clip of a train, and now everything that pops up are trains. So just examples of types of plugins that you can make. And so the list goes on. There's several plugins that you can build, that have been built, that will continue to be built. And we'll look at a few of them today, and I'll show you how to browse these plugins in the app as well. So you don't have to kind of, if you want to take a screenshot of this, go for it. But I'll show you where you can find all the plugins a bit later as well. This list keeps growing, right? Whatever the use case or workflow might be, if you can code it up, you can turn it into a plugin. So you can use these plugins in a number of different ways. So it all starts with, of course, browsing through our plugins repo. So we have a plugins repo, which I'll link right here. So make sure you star this repo, watch it, because this list is constantly being updated. In fact, there's a couple of plugins that I've created that I need to add, but the 51 plugins repo, I've dropped a link to that right there in the chat. You can browse this and see all the different plugins that have been contributed by the community, as well as kind of our core plugins as well. Once you see a plugin that you're interested in, go to its repo, look at the README, follow the instructions for installing it. Generally speaking, the instructions to install a plugin are quite straightforward. You just say 51 plugins download, and then the link to the plugin. So again, 51 plugins download, and then the location of the plugin. Of course, you could also do this via Python. What I just showed you is done via terminal, but you could also do the same thing in Python. Import 51 plugins as FOP, download plugins, download the plugins, and there's a few different patterns that you can use. I'll send a link to a notebook with all this information later. My apologies on this. I was hoping that this animation would just stop, but it looks like it just keeps going. Once you got your plugin, go ahead and load your favorite data set. You're going to look for this icon here. This is the operators icon, plugin operator icon. Once you click on it, you'll see it right there. You can browse all the plugins that have been installed. If you want to use a plugin, many of them are intended to be executed programmatically via the SDK. So if you wanted to execute a plugin via the SDK, you could do so like this. And of course, I'm going to share a link to notebooks for you, so you don't have to memorize all this. You can execute the plugin via the SDK or right there in the app. And then just kind of sit back and relax, and the plugin will do its thing. So it'll execute, and you'll have results on your data set. So how does all this work? Well, the core kind of abstraction that we use in 51 for a plugin is something called the operator. And so just given that many people are brand new here to 51, I'm going to kind of gloss over all this. But an operator is kind of a generator, and it allows you to trigger a custom workflow directly from the app. The operator interface looks something like this. You'll have some configuration, and you'll have context in which that operator has to operate in. That context is typically your data set as well as input parameters for the plugin to do its thing. And we'll see this in some code in just a few moments here. The anatomy of a plugin is something like this. Real quick here, if people are new, why would you gloss over operator sounds like a person? Well, because this webinar is intended to be for people who are already experienced with 51. So if you're not, that's the intention or the intended audience of this workshop is people who are already experienced with 51. And because people here are not experienced with 51, I don't want to scare you guys off. So that's why I'm kind of going over it at a high level. Of course, like I mentioned, I'll show you all this in some code in just a few moments. But yeah, that's why I'm glossing it over. So hopefully that's a satisfactory answer for you. Anyways, designing the plugin system, there's two kind of elements. So we have Python operators that are going to handle and run whatever computation or execution that needs to happen. And then there's the JavaScript for the custom UI. But the thing is, you don't need to know any JavaScript. You can completely write an entire plugin using nothing but Python. And I'll show you all of this in just a few moments. So you write your plugin in Python, JavaScript will take that Python and render it as a form on the app. So it's quite nice. And we're just going to, you can also, of course, write your plugins in JavaScript if you wanted to. I don't know any JavaScript. I'm a Python programmer, so we're going to focus on Python in this workshop. So plugin has a directory structure, and we'll see this once we start looking at some code here. But there are a few things that we need to absolutely define here. One of them is 51 YAML. 51 YAML is just going to declare the plugin. It will declare what the name of the plugin is, its location, the version number, as well as the operators that plugin uses. Then the kind of main entry point for a plugin is the dunder init. This will define and register an operator. Then there's requirements.txt. And this, it's optional, but it's a good idea to always include the requirements for that particular plugin. And then the README, which will tell somebody how to use this plugin. Remember that all of this information will be sent to you, like this entire recording will be sent to you after the fact, as well as all the links that I shared as well. So if you're coming in late, don't worry, you'll get all this packaged up for you. So 51 YAML is defined like this. So there's some information that we need to absolutely have, specifically the name of the plugin, the URL of the plugin. You can include a license description if you'd like, but we absolutely need the operators. And if your plugin requires some secrets, then you need to state what those secrets are so that we are able to pick them up from the environment. The anatomy of a plugin, it looks something like this. So we talked about operators at a high level, and there's a few things that we absolutely need to define in an operator, and you see these here. But essentially, an operator in the 51 plugin framework is just the user-facing components, and that allow interaction with the data in your data set. And an operator can accept parameters via the input form on the app or via the SDK. And it's going to take in those inputs and it'll saturate the context that the operator needs to operate in. It'll execute within that context and then return a result. And these operators can be simple actions like checking a checkbox to something more complex, like requesting annotations from some configuration backend, or even running a model on the data set. And they can be written here, like we have it written in Python, but like I mentioned, you can use JavaScript as well. And these operators can be executed directly by users in the app, triggered internally by other operators, or via the SDK, of course, or they could be used as building blocks to make more complex workflows. And so this framework gives you a built-in system for defining operators, inputs and outputs without needing to build the UI from scratch. And again, just be patient. We'll get to see all this in action. Simple example of an operator is on the screen here. And what this does is it just accepts text input from the user, displays that text back in the output modal. But like I mentioned, you can do more complex things like model inference, data transformations, or integrate with an external service. And we're going to look at a few different plugin examples, and I'm going to try to give you an overall vibe of what the pattern is like. And hopefully after a few examples, you'll pick up on this. So the anatomy of a plugin, continuing on here, this is the configuration for the operator. And so this just defines the core kind of metadata and behavior settings of an operator. There's a few that we absolutely need to define. One is a name, which is the operator's URI. That's formatted as you see here, plugin name / name, the label, which is the display name of the operator, and then some, of course, optional kind of basic metadata as well. So we'll look at a few examples at least to drive this home, so it's not as abstract. And the fact is, you could actually build and ship your own plugin this afternoon. And I'll show you how. This is kind of like where we're gonna go from here, right? I'm gonna show you how to use plugins. Then we're gonna look at several examples of plugins, implemented plugins, and then pick up on the, hopefully you can pick up on the general pattern. And then once you've kind of got that, one way you can implement a plugin is maybe find a model on Hugging Face, hack around with the model, write some code to apply it to your FiftyOne dataset, and then just make that code modular. And then what you would do is follow a format. So here would be, submit a PR to the FiftyOne's plugins repo, and list it there and have it ready for folks to use. But again, I'm gonna drive this point home after looking at some code in a second. So I'm going to share some QR codes with you right now, so you might want to have those phones ready. We have a Discord community. Let me go ahead and drop a link to that Discord community for you guys right now. The Discord community link is right here. Should drop it into the chat here if I could find the Zoom window again. There it is right there. So this is the Discord community that we have. I just lost my entire screen. Where'd you guys go? All right, there you go. All right, so join the Discord community. We have a plugins and panels channel that you can stay up to date. And here's some ways for you to kind of keep in touch with us. So go ahead, feel free to start us on GitHub, follow us on LinkedIn. You can hack around 51. Well, not necessarily hack around, but you can kind of play around with the app on a number of data sets as well. Of course, all this stuff is going to be linked in the email that we send out to you. So we talked about plugins a lot in the abstract, right? So let's get concrete now and just kind of drive it home. And I think the best way to drive it home really is to do two things. One, what we're going to do is I'm going to run through some kind of workflows using a plugin, or several plugins rather. And then once we go through kind of these workflows and kind of show you how to use plugins, I'm going to switch over and we're going to look at some code examples. And my hope is by looking at several coding examples, you kind of pick up on the general pattern. And so there are going to be pop quizzes while I'm going through this code. So make sure you're paying attention. So I'm going to be giving you guys pop quizzes. All right. So now what I'm going to do is I'm going to share my screen again. And this time we're going to jump into some code here. So real quick, we'll lower this down a little bit. Kind of the game plan for today is this. I'm going to use the IO plugin to load data from disk. Specifically, I have a data set here that's called Wonders of the World that has images, as you can see here, of several kind of, well, wonders of the world as they are. So what we're going to do is load all this stuff in into a 51 data set, right? Then we're going to make use of utils plugins and do some kind of basic stuff. And then what we'll do is we'll compute some image quality metrics. Then we're going to create a dashboard to analyze those metrics. Then we'll run some zero-shot models. Then we're going to compute embeddings using using a plugin that I've built to compute embeddings. We'll visualize those, and then do a couple other things. We'll push this data set to the Hugging Face Hub, for example. I'll show you how to do that as well. So that being said, let me just see if there's a question here. Yeah, big game plan. Yeah. We'll try to get through as much of it as we can. All right, so making sure everybody can see what we got going on here. So in the open source library, when you're using a plugin, we have to set this environment variable. So go ahead and set that environment variable. I've done it here already. To download a plugin, you can use the terminal and just run this command, or as I showed before, you can use the Python library. Before I get ahead of myself, actually, before I forget, because I have a tendency to forget, there's something I wanted to link you to, so that you can take this away with you. This right here is a quite in-depth notebook on using plugins. So I'll drop this here for you guys as well. Yeah, I dropped the Discord link right here. Were you guys able to see it at all? There you go. Discord link. Oh, you know what? My bad, y'all. I was sending the message to host and panelists. Oh my gosh, I just realized that I was dropping all the links to host and panelists. So my humble apologies. Here's the Discord channel. Yeah, no wonder. I was wondering why. All right, cool. Here's the Discord channel. There's the notebook I just showed you on using plugins. Here is a link to the Nemo Retriever Parse plugin that I mentioned earlier. Here are other links. This is I think the rest of the links I dropped to everyone. For those of you new to 51, though, here's a link to using the not getting started workshop, but a Coursera course that you can take for free. And here is what's intended to be an in-person workshop, but it will take you kind of from soup to nuts in 51. All right, apologies for that. Cool. So now you guys got all the links that you need. Don't worry, they'll be sent out to you in email as well. So now let's talk about how let's use some plugins now. Let's get started using some plugins. Like I mentioned, you can install plugins a couple of ways. You can use the library, right, the SDK, or you can just run things in terminal. My preference is running things in terminal. Of course, since I'm in a Jupyter notebook right now, I've just got it running as a cell with the shebang. Is this shebang or just bang? I don't know. Syntax here. First thing I'm downloading is I'm downloading from the Vox 51 plugins repo, and the names of the plugins I'm going to download. There's the IO plugin, the dashboard plugin, the Utils plugin, and the evaluation plugin. So we download those, we just run it. I've already got these downloaded, so we'll see that. I have a plugin here that we'll look at, and we'll use this to actually push a data set to the Hugging Face Hub. Of course, I've already got it installed, but you can just run this cell. You'll see this happen. And again, I've already installed all these plugins, but the pattern is the same. 51 plugins download, and whatever it is that the plugin is, wherever it is located. Now, you might have a plugin that has some requirements that you need to install. And so the pattern for that is once you've downloaded the plugin, for example, right here, we've downloaded the plugin. And to install all the requirements, we just say 51 plugins and then the plugin's name, right? So you'll notice here, it's a bit confusing because I didn't name my repo the same as the plugin. But this is the repo for the plugin, and then I have the plugin URI, right? So if I was to go to this repo here, and I look at the 51 YAML, 51 YAML is what defines the plugin's name. So that's what I use here, right? Same thing here. I've got a model here for using the, a plugin here for using Hiera embeddings, and then installing the requirements. MoonDream 2, probably my favorite vision language model. We'll make use of that as well. So of course, I've already downloaded all of these. So I'm not going to re-download them. All right. So now what we're going to do is we're going to instantiate a empty data set. Okay. So I'm going to go ahead and instantiate a empty data set, and I'll call it Wonders. Right. And so next what I'm going to do is I'm going to launch the app. So I'll kick open the terminal, 51 app launch. Right. And this will launch the app locally for me. Browser here. Right. Before I do anything else, though, we didn't talk about delegated operations in depth, but I'm going to kick off a delegated service. So a delegated service essentially treats my computer as a node, and just like delegates the computation there. This is nice because what this allows us to do, if we delegate an operation, we can continue doing work in the notebook or in the app without kind of having to wait for the thing to get finished. And it also gives us more insight into the progress of the computation as well. So I'm going to do 51 delegated launch. So you notice that I launched the app in one terminal, right? So in the terminal in which I launched the app, made sure that I had the Python process in which I launched the app. I exported a couple of environment variables. I exported a Mapbox token, even though we're not using the Mapbox plugin, but that's fine. Launch the app, open a new terminal, and that new terminal, I'm gonna kick off a delegated operation. Of course, this is all covered in the where was it? The notebook I sent to you about using plugins. So get it started using plugins. So it's all right here. In depth. All right. All right, cool. So I've instantiated an empty data set. So let's go back to the app here. Let's select the data set. In this case, it's the Wonders data set, right? No samples in my data set yet because it's just empty. To open, from here, in order for me to open the operators panel, what I'm going to do is hit backtick the keyboard, and I'm going to type in import samples, right? So the import samples is a kind of 51 core plugin. And real quick, I see a question pop up. Sorry. The speaker shared links to course on Coursera, Kaggle. So you'll get all the links in the recap email that'll be sent usually by Monday. So you get all those links there. But if somebody has it handy or somebody can scroll up and share it, that'd be very helpful. All right, so here what we're going to do is we're going to import samples, right? So I'm going to import media and labels, the data set type. So looking at this, right, you see the Wonders of the World data set is a image classification directory tree format. In 51, you can import any of the common data set formats using this plugin. However, if you have a custom data set format, you can import that as well. It'll just require you to write some code, not a lot of code, just a loop. In this case, it's the image classification directory tree. That's the data set type. The label field, I'll just call this, how about just ground truth? Ground truth, yeah. The directory in which this lives. So we'll go here, we'll go to workspace, we will go to everything is in the plugins workshop. When is the world? It's nested, so I got to click on it twice, right? So this is the directory where all of my images live. I'll choose that. I will click on the bottom here, execute, and this thing will run. Now you can see here, I've got all of my samples imported. So let's just add a shuffle just to kind of shuffle it up. All right. All right. So you can see we got all the images imported here in the app. Something I think that's useful to have would be some metadata, like the width and height of each one of these images. I don't have that yet, but we have the plugin, right? When we install the Utils plugin, that gives us access to the compute metadata operator. Right, so I'm going to go ahead and compute metadata on the entire data set. Click here, hit execute, then we'll get metadata information on the entire data set. So now each image has metadata. Of course, you could filter in the app and all that stuff as well. For example, if you want to get, very wide images, you could do that. If you want to get very tall images, you can filter and do all the stuff that you are familiar with doing in the app. All right. Next, what I'm going to do is, let's just compute some more information about what is in our data set. So recall that I installed the image quality issues plugin, right? We saw that happen right up here, the image quality issues plugins. So let's go ahead and just compute some values here. Let's do image quality issue. Let's compute the blurriness of the image. Still on the entire data set. We'll delegate the execution, right? We'll hit schedule here. When you delegate an execution, if we go back here, you'll see that we're in the terminal where I launched the delegated service. I'm able to see all the kind of progress here. All right. Now let's go ahead and we just did blurriness. How about brightness? Let's compute brightness as well. Same thing. I'll click delegate execution on the entire data set, hit schedule, and I can check the process of the operation right here. All right. So this will just take a minute or so to run. And while this is running, one thing I want to start showing you is now that we have all this kind of additional information, you'll notice that we don't have the blurriness or anything showing here yet. So I have to refresh the app. So I'll hit Control R or Command R to refresh, and you'll see that we have blurriness and brightness as well. Let's get the blurriness and the brightness here. This thing is just running another 20 or so seconds. But in the meantime, we can look at some other information. Once I have all this kind of metadata computed, I've got the blurriness and brightness. Maybe I want to do some type of high-level analysis, right? Some EDA, if you will. You'll remember that we installed the dashboard plugin, right? So that was all the way up here where I said plugins download the repo and then dashboard plugin, right? These are several kind of core plugins that I installed from this one repo. So I've got the dashboard plugins here. And what I'm going to do is just create a custom dashboard. So I'll go here, go to dashboard. Let's add plots. Maybe one plot that I want is, let's do a categorical histogram. Let's say frequency of class, right? And we'll make the categorical field be the ground truth label. We'll sort it by frequency. We'll create that plot. And then I can add more to this, right? So I get add an item. And maybe here I want to do maybe a scatter plot. And the scatter plot, we could say maybe is it height by width. The Y, we'll make it metadata height. We'll call it height. The X, we'll make it metadata width. We'll call this width. We'll go ahead and create the plot. Right. And let's just create another couple of plots while we're at it. So let's do a plot. Let's do a numerical histogram. We'll call this blurriness. Blurriness. Let's make maybe, I don't know, 25 bins, something reasonable, I guess. Maybe 50. Leave it at that. We'll create the plot. We'll add another item. Let's do another numerical histogram. Let's do brightness. Brightness. There you go. And let's do it again. Let's do 50 bins. All right, create the plot. All right, cool. Of course, you could edit the layout. You can move stuff around however you want. Snap it into place. Do this. And if you find yourself doing this type of workflow, like for every single data set that you come across, you can just say, save this. And maybe you could just say dashboard. Right. So now you don't have to go through all those button clicks over and over again. It's saved there. So the interesting thing here is now, actually, these are interactive, right? So I can, let's say I'm curious as to, sorry, doing the wrong, do the lasso select. Let's say I'm interested in which images are here. It's interactive, so everything filters down with it. So the images filter down, the count filters down, blurriness and brightness values filter down as well. So it gives you that opportunity to really explore your data interactively, right? So this is a nice feature of the dashboard panel. And then from here, you could do whatever, like, you could tag an image and, tag it with some type of tag that's meaningful to you, right? So this is, using the dashboard panel. So quite nice to use. Let's go ahead and just make the grid smaller, right? Now real quick, what I'm going to do is you'll notice that we did install a plugin here. I think, did I install it? Yes, the zero shot prediction plugin. Just make sure it's actually installed. I've already got it installed. And what I'm going to do here is actually using the zero shot prediction plugin. Actually, let's not use the zero shot prediction plugin. Let's just use the MoonDream 2 plugin. MoonDream 2 because it's relatively quicker. And I just like that model a lot. So we'll use the MoonDream 2 plugin. I'll use this revision because I know I already have the weights downloaded. We'll use this to do maybe maybe a caption. I don't know. We could do a short caption and maybe the output field. Yeah, let's do captions. Yeah, we'll just do captions. I'm actually scared that this will take longer than we have here. But just an example of what you could do with the MoonDream plugin. You can fill out the operator, stuff like that. Let us actually just use the zero shot prediction plugin. Let's do zero shot classification. We'll just use, let's use clip because it'll be quick. Let's import it from a file. Let's upload here. Let's actually do this. Drag and drop it. If I could drag and drop it. 1 second. Let me find the file. So just for context here, like this machine that I'm in, I'm SSH'd into my GPU rig. So this is why when I click here, it's looking for it locally. So we'll do that. Got the wonders name. Let's do clip predictions. Delegate operation on the entire data set. I think I've already got the model downloaded, so that'll be quick. And clip is nice and fast anyways. And so we can see here, we can monitor the progress and all that right here. So you see clip runs quite quick. In the meantime, I think I saw a question pop up in the, okay, no questions or anything popping up. If anybody does have questions, now would be a good time while this model is running. Earlier webinars are published on YouTube. Publish the links to the previous YouTube. Yeah, I think we replace them like every time. So if we go to Voxel 51, here is our YouTube channel. And you can see all the previous videos that we have up here. So there might be one here for plugins already. But I think it gets overwritten or something when the new ones come out. But you'll have a link to this recording as well, so no worries. All right, cool. So it looks like clip is done. So we'll go ahead and hit Control R to get all the stuff in. So we see we have clip predictions here as well. And so now what we're going to do is I'm going to evaluate. So you can remember looking right back here to the top of this notebook, I downloaded the evaluation plugin. So I'll say evaluate a model on the entire data set. Prediction field will be clip predictions. Ground truth will be the ground truth. Evaluation key would be eval clip. Let's just call it that. Let's do a simple evaluation. Classes, they should just be the, let's just use the observed ground truth actually. Boom, execute. We'll hit execute. All right, so now we have the evaluation key registered here. And now what I'm going to do is I'll open the panel here, go to the model evaluation. This is the model I want to evaluate. And let's compare it. I guess there is no other model per se that is compared against. It's compared against ground truth. But if I had to run a different model, for example, like Siglip or whatever, like if I ran like a different model, I can compare clip against that model. But right now we're just doing everything for ground truth. So here we can see, we can also open this up just like this on the side panel. And we can see how well the model performs. We can open up the confusion matrix and we can, kind of click in as well. So sorry, my color scale is a bit off on the screen, but I can click here and see, okay, there's 5 that were Angel Falls, but clip thought they're Machu Picchu. All right, let's take a look at those. All right. And you can see here that, okay, yeah, clip was definitely wrong. And again, here's 4 that were ground truth of Great Wall of China, but clip thought they were Christ the Redeemer, right? So we can click in and kind of figure stuff out like that. And of course, we can tag a sample here, maybe say needs review or whatever. And it's quite, however you typically would use 51 workflows. Of course, you'd go through the Getting Started workshop, you'll get a sense of that. Great. So this is just an example of workflows using 51 plugins. Now let's just spend just a few moments here just going into how a plugin is kind of constructed. So as promised, what I'm going to do is I'm going to show you a few examples in code, and then hopefully this will help you kind of figure out at least what the pattern is. I think a easy, straightforward place to start is this Nemo Retriever Parse plugin. We're not going to run this plugin because obviously I don't have documents here, but what I want to do is this. I'm going to pull up the form for Nemo retriever parse, right? So remember, there's a few things that we have to define a plugin. One of them is a README, which you see here. This will show you exactly how to run this particular plugin. The other is 51 YAML. 51 YAML defines the name of the plugin and what the operator is, right? So this operator is the entry point to the plugin, right? So keep this in mind. Run Nemo retriever parse. This is our entry point to the plugin, right? If I go to init.py, this has a lot of information here, but most of this is essentially just, it's required for building out. We need Python to define how the JavaScript is going to hook to that Python and render everything in the app. But I just want to call out a few things. One thing here is this operator config, right? So take a look at what we have here. When I hit backtick, what shows up here? Parse Nemo retriever parse documents with Nemo retriever parse, and then run Nemo retriever parse, right? So this is the operator config. This is the label, which is showing up right here. This is the name, which is showing up right there, right? So this config part is what we need to define so that this plugin shows up in the operator menu. Great. Now let's click on this. All right, you'll see here what's happening. It's asking me for an input. That input is the NVIDIA API key. All right, so what do you notice in the resolve input function? You notice here that I have the form, right? So I define inputs type just object, and I have a form view. Well, what do you see on the form view? The label, Nemo retriever parse, and then the description. Note you'll need to set up an NVIDIA API key to use this, right? This is everything right here, right? This is the input form. We'll see a few examples of this in a second. But the most important thing here is the entry point to the function, this run Nemo retriever parse, right? You can define run Nemo retriever parse. Like in my case, I defined it in a separate file just to save lines of code in it. But this right here is what executes the plugin. So we have a context that we need to saturate. How do we saturate the context? Well, we need to have a data set. And so that's what this does here. The same, the context, the view that we're working with is just everything that we're looking at here. Context that we need is the API key, right? So I could put in my API key here, and hopefully you guys don't, steal my API key. Let's just do this here. Have my NVIDIA API key, right? If I pass in my NVIDIA API key, well, I can then pass in like other information. This right here is primarily for well, actually, the maybe a bad example of a plugin pull up, because I actually don't need these fields. But one thing I want to call out is just this run Nemo retriever parse, right? We'll see a few of these, and hopefully it'll latch onto you. But I'm going all the way here to this run using the utils that I have. Where is it? All the way to the bottom is the entry point, right? So this entry point takes the data set that I'm working with, so the context I'm working with, in an API key, right? So this front end that we see here, is what calls this function. Implicitly, this front end is going to either work on the entire data set or what it is that I'm currently looking at. So if there's a subset of data, then it'll work on that. And so that's the implicitly what gets parsed in here. And then also the API key, which I parse in here, right? Let's try this home by looking at another couple examples, specifically MoonDream. I think this is a better one to look at. All right. So when we open the operator, right? Hit backtick, that opens the operator menu. So again, hit backtick opens the operator menu. I see run MoonDream 2 and then the name of the operator. So if I open up init.py and I look at the config, what do I see? The label run MoonDream 2 rendered here, name MoonDream rendered there, right? Now I resolve the input. So what's the input I need to take from the user? So first I just define this inputs. This is internal 51. Define the inputs, and then I have a drop down menu, which is what would you like to use? You see here, this is not necessarily like the way I define it here. Like inputs dot will define the placement, right? So you can see I've constructed these drop down menus first, right? So I have the drop down menu for how I want to use MoonDream, a drop down menu for how I want which revision I want to use, and this is essentially just reading from a dictionary that I've defined elsewhere. But the most important part here is this. Important part right now is this, right? The revision. So if I click here, you'll see which revision would you like to use, right? This is right the label of that dropdown, right? So I define the dropdown. I say the values I'm taking are from that dropdown, and I'm labeling this revision, right? Which revision would I like to use? It's a dropdown. Of course, you can see the description there. Likewise, what do I want to use MoonDream to? MoonDream 2 for? Another dropdown, right? So this is all defined here in Python. Right? So for example, let's say I want to use it for object detection, right? And so here's just some conditionals, right? If I want to use it for captioning, then what I see in front of me changes. I now have a radio group, short or more descriptive captions. If I want to use this for visual question answering, just query, then this input changes, right? It's just a conditional. If I want to use it for object detection, again, the input form changes. What do I want to detect? And you can see everything's just lining up right there. If I want to use it for pointing, again, likewise, what do I want to point at? And all the values the user selects here are going to be saturating a something called the context, right? And the context will be saturated with, this variable name. This variable name is essentially the context is a dictionary. I'm going to add to the dictionary this key. The value for this key is whatever the user selects, right? So query will be called query text. If they detect, then object type, so on and so forth. All of this stuff that the user fills in is the context. Context gets saturated with the user's input, right? Once we have the context saturated, we need to execute, right? And that's what this is doing right here, right? So the view, of course, the entire data set or the subset that I'm working with is implicitly saturated here. You can see here that common to every single operation for MoonDream, there's common things that we need to get from the user. That's the revision of MoonDream that we want to use. That's the operation, and then the output field. Right? You'll notice that no matter what I change the operation to, the output field stays the same. Right? So we'll grab these variables here from the context. I'm going to grab view, revision, operation, and output field. I'm capturing that based on the user input, right? And then I'm creating a dictionary of keyword arguments that depend on what the user selects. Okay. Once I've got all this information, I'm passing it to the entry point of the plugin, which is this run MoonDream model. So I'm passing in the data set, the revision, the operation, the output field, and the keyword arguments, which I'm pulling in from here, right? And so if I go to this run MoonDream model, I defined it in a different file, just to save space here. Right, I'll scroll all the way to the bottom here. This is the entry point, right? All the stuff that comes before it, this is just, you could think of this as just arbitrary code and logic that I need for the model to do what it needs to do, right? For the model to behave the way I want it to behave and output stuff the way I want it to output, so on and so forth. It's arbitrary, right? The main thing that we need to concern ourselves now with is this entry point. So of course, the entry point takes the data set, which we implicitly get from here, the operation, which we define here, the output field, which we define here, the revision, which we define here, and the keyword arguments that change based on what it is that I'm using the model for. Right. So hopefully that's hopefully that's becoming a little bit clearer. I see a question here from a few minutes ago. Do you have plugins or native integrations to any of the common data labeling platforms? Yeah, we do actually. To everything that you mentioned, actually, for LabelBat and CVAT, we do have the integrations. So let me just go ahead and drop a link to that right now. Box 51 docs. So you take a look at this. I'll drop a link to the chat. I can find the chat. There it is. All right, cool. All right, now you guys better be ready for a um pop quiz, right? Because we're gonna look at another plugin, all right? We're gonna look at another plugin, and I'm gonna quiz you to see if you picked up on the pattern, right? So in this case, let's look at this other plugin. This is the AIM embeddings plugin, right? So I'm gonna put, open the operator panel, hit the backtick button. I'm gonna type in AIM, right? So real quick, this information up here, which one of these files is it going to be located in? Anybody want to take a stab at that? Right. What I see here, where would it be? Which one of these files would I find that in? Operator. Oh, okay. Yeah. Here. One step ahead. Yes, it will be in init and defined in the operator config, right? So what do you see here? The name, compute AIM2 embeddings, and the label, right? All right, cool. Now, in this class that I define, this AIM v2 embeddings, everything that I see on this input form, which function, or rather which class method do I define these in? Hint, it's already on the screen. I'm gonna wait for y'all to type. I'm not going till you go. Yes, resolve input, right? So in resolve input, right? So we always start off with this. This is just internal to 51. This just lets us know that we're collecting inputs from the users, and they're all objects that we're collecting, Python objects at the end of the day that we're collecting. I have a model dropdown. Choose the AIM v2 embedding model you want to use. Well, that's right here. Choose the AIM v2 embedding model you want to use. Right. And so I just construct the dropdown list. This is just defined using a dictionary. If you're curious, you scroll up here, and the dictionary is defined in this uh, utility file. But I click on this and I see all the um, uh, models that I could use, right? And this is all right here. All right. So, real quick, can somebody tell me now? Once I select one of these supported models, right? Once I select the supported model, what variable name, or rather, what key in the context does this get saved to? Yes. Yes. Awesome. Thank you, Rishi. Thank you, Russell, for participating, and Rob as well. Rob, Russell, Rishi, Triple R. Thank you guys. Yes, you get saved to model name, right? And now here you can see I've got a radio group, which embedding approach do I want to use. I'm not going to get too much into this. You can read the README on this. Right. And now let me ask you this, kind of a similar to the last question. If I choose this, right? If I choose this as the value, this will be saved to in the context dictionary, there will be a key called embedding types. What will the value of that key be? Yes, exactly. It will be mean, right? Because that's what I'm saving it to, right? And of course, the name of the field to store the embeddings in, so on and so forth. We won't concern ourselves with delegation and everything here. All right, cool. So everything that okay, wait. Let me, I don't want to give it away too much. All right, so I've saturated my context now, right? So I've saturated my context with all the, essentially with a dictionary of key values that are going to be used now. Which method is going to now take in my entire context and do something with it? I think I might have given away. But execute, right? All right. Yeah. So execute, right? It's implicitly, going to take the view that I'm working with, whether it's the entire data set or if I'm having a subset of the data set, right? I'm going to have the model name, the embeddings field, the embeddings type, and all of this is going to get passed to the entry point of the plugin, right? So this entry point of the plugin, let's go ahead and look at it. I'm importing this from another file. So let's go up here, embeddings, all this stuff here. You could think of it as just arbitrary code. This is just what I just need to do and write all of this logic so that the plugin does what I want it to do. But this is the entry point here, right? This is the entry point, right? So once the context is saturated, sorry, I went to the wrong place. Once the context is saturated, I pass everything to this function. This function will just do the thing that it needs to do, right? So now here's another I guess another question. All right. If I was to now look at 51 YAML, right? If I was to go into 51 YAML, what would the name of this plugin be? The answer's on the screen, but just think about it. Think about it. Name of the plugin is that, right? And you'll see here the operator compute aim v2 embeddings, right? So let's go back here to init down here. This is the operator name, compute aim v2 beginning embeddings. And so this is kind of the blueprint. The rest of this stuff, like you can copy any one of my plugins here. You can gut everything. And the only things you would need to implement now would be the input, right? Like the resolve inputs. I mean, the config, of course, like, implement the config, implement the resolve inputs, implement the entry point to this plugin, uh, and just let it rip, essentially, right? Well, we have to register the plugin as well. I mean, it's just this registering the plugin is just whatever the name of this thing is, but that's all there is to it, really. The hardest part is just like parsing the logic for um, for the plugin to do what you want to do, right? So now let's just look at just a simpler example now, right? So here's just a real simple plugin, a toy plugin, if you would. This plugin, all it's going to do is it's going to compute the area of a bounding box and the surface area of a segmentation mask, right? Yeah, config, resolve, input, execute. Yeah, basically that's it. The output resolution typically will happen in the entry, like, in this kind of entry point function. All right, so real quick, um, all this stuff is just extra logic, right? This is just extra logic code that I need to do, handle what I need to handle. Um, Now, this is the entry point into the plugin, right? Now, um, sorry, you're talking about a use case for this particular um plugin, like this plugin. Okay, so real quick, all this plugin does, this is a compute areas plugin. So this is just computing the area of a bounding box in an image. And so maybe this will give you a sense of kind of how much, how big a object in your image is relative to the entire image, right? So that's one use case, and I'm sure you can extrapolate beyond that. Uh, you can also then compute the surface area of a segmentation mask, right? So this could, again, you could just think of the many different ways you could use this for. So for example, let's say you were working with car claims data or damage of a car. And if you want to assess the severity of damage on a car, well, if you've got the segmentation mask for the entire car, you can compute the area of that. Then you can compute the surface area of the um, damage portion of the car, and then take the ratio, and from there add some downstream logic to classify how, or filter on severity or something like that, right? That's just off the top of my head. Anyways, real quick, this is the entry point. Which function? Oh, sorry. Okay, so taking it back real quick. In the class which defines the operator of the plugin, which function which class method is going to call this? Which class method of the operator is going to call this entry point? I know you know it, Rishi. I know you know it, man. Like it's the answer's right there in yeah, execute. Yes, exactly. Adipto, execute. All right, cool. All right, so in please share your content. That's a good one. All right. All right, so we're gonna, yeah, execute is going to call this. Um, what do you think the user is going to need to input, right? Based on what it is that this function needs, what do you think the user is going to have to input? Right? All this, the field name, computation type, whether they already have polylines or not, right? Which method uh, in the operator do I uh, define all that? Any guesses? Any guesses? I'm just chalking up to you guys being shy. Um, resolve input, right? So let's just real quick, let's you know ignore all this stuff. This is just logic that I need for the thing to do the thing I need to do. This is the entry point to the plugin. The entry point to the plugin, I need to have data set, of course, and then I need to have these other arguments. All right, so if I scroll down here, I look at the execute method. All right, the execute method will take the context. The context is going to be the data set that we're working with, the field name, computation type, whether we have polylines or not, saturate the context with all this stuff, pass it to the entry point, and then the plugin will run and do its thing. And of course, all of this I capture in resolve input. So just this here. Actually, I think I'll just do this. I think I have the code already on GitHub here for this. Yeah, so pull it up here. All right, so define our operator, compute area, right? We have the name, the label. The user has to tell us what computation type do they want. Do they want bounding boxes or do they want surface areas, right? And depending on what they choose for the computation type will be one of these values, right? So if I click on compute bounding box area, then in the context, the dictionary will have a key called computation type, whose value is bounding box area. And of course, if I go down to here, going back to the entry point, computation type, right? Let's say I want to do the surface area of a polygon. Do I have lines? Yes or no, of course. Has polylines, default to false. The field name that contains the information that I need, fill that out. And of course, you could choose to delegate the execution or run it on the entire data set or the current view. All this stuff that we get from the user input saturates the context. Once we've saturated the context, we'll execute. How we're going to execute, we'll grab all of these arguments from the context, pass it into the entry point of the plugin. The plugin will run, do its thing, and we'll have our results. So that's basically it. All right, so I'll pause there. That's you're gonna get the recording of this anyway, so you'll have all that stuff there. Thank you for sticking with me, everybody. If there are questions, I think that would be a excellent time to ask those questions.